Okay, ich bin Cornelia Fermueller und für die, die es nicht wissen, ich mache hier das DC, Greater DC Chapter. Wir haben eben auch die Virginia-Leute, die Maryland-Leute und die Washington DC-Leute. Und ich komme aus Computer Vision oder bin noch immer in Computer Vision. Und meine Spezialität, okay, ich bin schon lange im Feld, wie ihr sehen könnt, aber meine Spezialität ist Motion, unter anderem. Und so habe ich eben über die Jahre gearbeitet. Was wir haben, ist, wir haben Kameras, mit denen wir die Welt beobachten. Diese Kameras für uns sind oft auf Robotern. Und zum Beispiel auf Drohnen, die müssen Tasks machen, wie hier gezeigt, zum Beispiel durch einen Gap fliegen. Und die machen um, actually, I'm gonna switch to English. They're gonna make reconstructions of the world. They build models of the world. They have to estimate the motion that they are moving, that other things are moving. And I also do motion also involves action. So I have been looking at humans doing actions in the manipulation that are doing manipulation work for a long time. So under the hood, you have a lot of things. You have to understand what the objects are, how the people are moving. For example, one project we got a lot of attention. We learned from the YouTube video what people are doing in their cooking, how they cook a recipe. And then we developed some grammatical representation to represent these steps individually and executed them on a robot. So I have, and so that's what computer vision is about. And a few years ago, about 3 years ago, Irina Mureșanu, who is a concert violinist and professor at our School of Music, got this idea that she would like to help people learn whatever, do something with violin ups. And then our boss brought us together. Here's a woman who knows how to do action understanding. So we got together and started thinking about how can we apply this? What can we do? What is necessary? The idea was to develop something in violin for students to help them. We started then out developing, formulating the first ideas. What is actually useful for violin students? First got some commercial grants, and we were picked up for a grant challenge at the University of Maryland. And recently also we teamed up with Shihab Sharma, who a friend of ours who is expert also on audio processing. And we got funded for understanding in the science of learning for these aspects, scientific aspects also. What's under the hood? How do you teach with an AI platform? What does this mean? It's interesting because you're doing a motor learning task that also involves perception. So there are many scientific questions that haven't been touched yet in this domain. So there are many benefits for learning.
Cornelia, can I throw in a question?
Yes, please.
So can you go back one slide?
Yes.
So it is about the learning of playing the violin, right?
Well, we developed, we set originally, yes, we are developing an app, you will see, a program that will assist the violin students in learning the violin. So, but when we started out, we didn't even know what we're going to do, right? And then being at the university, I mean, general, we want to do science too. So it's on the one side the product, but on the other hand, there's also scientific questions to be asked. Because what does it mean to relate the motor activities. You have to learn all this motor control. And you're learning this while you hear you to yourself, while you get instructions from a teacher. How does this actually happen? And then you want to do something in and up to be a substitute teacher. So, yeah.
So the idea is to see how much of this you can generalize to other tasks of motor learning.
It will be in general, but right now there's many questions even on the violin. Yeah, we do.
Okay,
we
yeah,
have spread already out, but we're doing it specifically for the violin, having the expert knowledge of Irina, having vision expert and some sound expert, how to put these things together. And then, yes, then we will also attack it in generalization first to other instruments. To rhythm learning, I'm going to speak a little bit. We thought already about how to teach rhythm.
Cool.
So, yes, there are many benefits. I think in the classical education that we have in Austria, it's much more, we are much more aware that we need a holistic education as the Greeks already had it, right? Art is part of education, but in the last decades in the US, this hasn't really been done. There's a lot of only STEM, and what students can escape other things that actually contribute. And there is here and there evidence. It's also getting now into popular books like René Fleming just put out a popular book on benefits of music on health and also brain development. So if you get good at music, you also get better. There's already evidence in language skills. Definitely, as you have improvements in any part, syntax, semantic, but also acquiring a second language. You get obviously benefits for coordination, memory, because you memorize these pieces, synchronization, confidence, planning. So there's evidence here and there from cognitive neuroscience studies, but there could still be lots of research to make this really systematic. It's more here and there to make this a real science. But it's clear that if you listen to music, but more it's really the engagement. If you sing or learn how to play an instrument, you are active and your brain involves this perception, action, memory, and it helps you with many other things. Creativity. So far up, we also looked what is the demand, and there's about 250,000 students in the US that are playing the violin, and about 10 million in China, where it is very popular. And we asked then educators. We had many interviews with violin teachers. What are their pains? Where would they see technology? What would they like? It was also just a pandemic. At that time, violin teachers had to teach over Zoom. And it was very challenging for them, not only for technical reasons, because there's a small delay. So playing together with someone is really challenging, something that could be fixed. But then they have to see the students through a Zoom app, and the student isn't standing there perfectly, so they get all the views, so they have occlusions, they can only see a part of it. classically, the violin teacher goes to the student and corrects him physically. All this is not possible. But this has become, as I hear, also challenging now in real life to touch anybody. So we talked to these people what they could see for technology development, and developed our how we're gonna go about to make now something that is a platform and can help students. And so we came to these goals that we wanted to create an application that looks and listens to the violin students, eventually at all levels. But we start with the beginner and add up more and more, going to more advanced and eventually to very professional, very high, with lots of qualities. And the capabilities we wanted to do is first just correct the posture, which is challenging for a long time. Students struggle with it for 5 years to really get it correct all the time. The slouching, the violin too high, not right stand, balanced, and then attack as the next bowing techniques. So there's many different strokes that you're playing as you play the violin. And there you have to get them right too, and you hear, you listen, how do you go about to tell the student what to change? And then as it gets more advanced, we will go into the quality of tone production. What does it really mean to produce a very good tone? How can the expert knowledge help? And another feature we will be having in our app is curriculum assignment. And to that purpose, for the beginning, we are recording, not me, but Irina, the musician, she records the whole repertoire of exercise pieces, so-called etudes, in a very unique way. They will be annotated, curated, and then we will use those etudes to evaluate students as they go on in order to tell them you're not mastering this capability right. Your détaché is not right. You have to practice this and that. And in this process, obviously, you want to give feedback via an application, via AI, that explains, but shouldn't cognitively overload the students. And another challenge is that isn't done we have all these Coursera courses, but they are generic. What we want to do with this step is go a step further and individualize it. Tell the students, this is what you don't master, so you have to practice this particular. And why is it interesting also from scientific point? I mean, not just scientific, but also, as I said, I called the talk Democratizing Music Education, because it opens instrumental education to all. Right now, it costs a lot to have violin educations as a private student. So we think about this could be, I mean, it could be used in addition to the teacher, maybe have less lessons, saving, but definitely to in between the lessons, even the student is left alone and he makes mistakes. So we hope that by practicing with the app and getting information about how he's playing, the app will collect statistics about his playing, and that information can be shared by students, the parents who also want to help, and of course the teachers who would get some summary statistics of what the student was doing. And here in the US, many students are learning instruments just in the school, starting from middle school, and then in the high school, music is often, students participate in bands or orchestras. They bring them up they do not get through that process individualized education. They just get what they get through this band education, a little bit instrument. So, and many students then also drop it because they don't make enough progress. So an app like that could help. And there is general demand for online education. As I mentioned, it also helps the teachers and parents, especially what we found during the pandemic. They really want to help their kids, but they may not know how to play the instruments. An app like that can help them. From an intellectual point also, because it does relate perception through the motor system. So we're hearing, when we practice, we listen to ourselves, we get some feedback also, maybe we look at ourselves also, or the teacher tells us. So it's this relationship that is interesting to study. Relationship about how we learn through perception feedback to control our motor system. And this is obviously a digital platform that we want to take even a step further than what is classic platforms, MOOC education. As we want to individualize it. So what are our first task that we have been addressing was posture analysis. So the task was with the expert knowledge, we just looked at what are students generally doing wrong when they play the violin. So they could be putting their neck forward or sidewards. They can have the violin hand too angled, inwards, outwards, or the shoulder on the bowing hand, the shoulder can be too high, the elbow can be too high. So the body itself may be leaning forward or it may be slouched. The feet may be crossed. Oh, wait, crossed, that's obvious, right? Or you may not be balanced. Things like that. And we imagine this, that then the app will tell you what you should do in order to correct. For example, put equal weight on both feet here, or lower your elbow hand. So here's a beginner student that was recorded in our lab. I think there was music too, sorry. Okay, so there's music too. She plays, and what it basically means, back, no, okay. As she plays, then the idea is we're gonna fit this model to it to have a standardized representation, a skeleton representation. People come in all sizes, height and so. And from that, then we can evaluate, taking the skeleton measurements, what is wrong. For example, here, she's arching her hip, which you can evaluate by the angle. But how do you go about this? You may have seen there is lots of technology has been invested by all the big companies now, and they are very good. They're getting better by the day of estimating exactly these skeletons, and sports apps are based on it. And we tried, of course, out the latest, but they do not work sufficiently good enough for violin playing. The reason being you have a lot of occlusions. Occlusion means one thing is in front of the other, you can't see it. Also, there's an object in front. Most of these pose estimators, they will work if there are no objects involved. So in sports that you're just standing there. So here you see some problems, for example, here inversion in the legs, or a swap, extra points here on this third in this third image, or impossible transitions. So we needed something that's better than that. And that came then from the idea, and we're having both sound and vision. And the sound contributes a lot. And the way you're moving, that's the way the sound comes out. So there's a causal relationship. And that's exactly what we wanted to explore in order to get really good skeleton models that can be used for pose estimation, but then also beyond that for violin, for bowing motion, where you really need the fine details of how it's done exactly. So for that purpose, we first set up and you do a data collection. We have a lab that's so-called a Vicon lab. So there are special cameras, infrared cameras that are here. We put them here on tripods, and they're also hanging on the wall. And they record in infrared, and you put markers on the people. Okay, so it's a long calibration procedure. Multiple of these are collected. So you have all these cameras hanging here, 1, 2, 3, 4, 5, 9, 10, that are looking at the humans. And because it's all calibrated and you have this infrared on special markers, it's possible to get very good ground truth. And that ground truth we need to train machine learning algorithms. So it's used for training. So here you see some of the cameras. Here a student. We then put them in a suit and put the markers on the suit to make this faster than the setup. And altogether we collected 639 videos from 12 players that were, after the setup was done, they played for many different things, starting first just with bow strokes, building up to scales, and then some standardized pieces. They also got feedback in order to correct. So we had on that, they played etudes, and then at the end, they played some pieces of their own likings. And markers are here put on essential parts of the body. And then we also put the markers on the hands to have exact knowledge of how the hands are moving in these things. So out of that, recording this, you have now the video for multiple views, you have the corresponding audio, and you have the 3D pose because you recorded with this Vicon sensor. We also put markers, you can see a bit on the bow to know exactly where the bow is, and from which then in post-processing we can compute contact with the violin and actually pressure with the violin. That's still going on. So this is a very, we recorded from 12 people, but you do this for your data collection, but it's an effort, and the kids have to come in, and it takes a few hours to just set them up by the time they want to go home. But so in the meantime, we actually, through University of Maryland has now a new program called Immersive Media. So they're training students from the arts and computer science in the co-training. So to go out and do immersive media, and as part of this, we're working with them and could acquire now equipment for a new lab where you can actually do this markerless. So you don't need this huge setup anymore. You just go in and the software is there to record from humans. But of course, it's not that, it's a little bit less accurate. So I will mention, we do need, again, to train AI to get to better accuracy so that we can use the data. So these are steps that are involved for machine learning scientists. For evaluation, we also collected other data sets just from YouTube where people are playing, just freely over Zoom. There's lots of available for training and evaluation. So then I promised we developed, that's what we're doing, AI. We're developing AI, and here I just outline a bit how such a network, so you train a neural network, and that neural network gets its input, it gets the video from which you can run already off-the-shelf 2D pose estimator. 2D is much easier than 3D, right? So just the frontal parallel. So you train this 2D, just run it, and that's basically then your input. You have the raw audio from which you extract various features, and then you combine this audio and video because there's a causal relationship. The way you're moving, that's the way the sound comes out. And in this case, after experimenting for a long time, we figured out that we had an incremental network that first computes pose features, then goes to velocity and acceleration, and through various integration mechanisms, then comes out at the other end with 3D pose, a very improved 3D pose that then will serve for many things that we have already done and we are planning to do. So one of these things is, as I said, the first task, which is our first product, is the pose estimation. So that's what an output would look like. The person playing. Here this person gets feedback. She was putting the arm too low. After being told it's fixed. So this is then the output, or I'll show you.
Sorry, can I interrupt for a second?
Yes, please.
You showed the model earlier, and it looks like you also use audio as an input, right?
Yes, I do. Yeah, I mean
that's actually very, very interesting, right? Because I mean, it kind of makes sense. You have the data, and it's very interesting to investigate. But yeah, the relationship between the 3D pose and the audio is exciting.
Yeah, thank you. Yeah, that is the thing that fixes it, right? Yeah. Mm-hmm.
That's the correction mechanism.
Yeah. Mm-hmm. Mm-hmm.
Okay.
So by putting them together, you get better. Mm-hmm. Yes, so here we compare, and it's in the fine motor movements. There's this fixing, obviously, that I showed you at the beginning. When there's occlusions, it helps. So if you start, there's really good software that Metaput has put out, or the most software that everybody uses is Google, but it still has, if it initializes it wrong, if you only use vision, you can never correct. But with audio putting together and going a step back only to 2D, we are able to. And it is, okay, one thing is in the initialization, some cases don't work, but the other things are also in the very fine motor movement, like here, bowing motion shown, the ground truth in green, and that's how our software, we called it, biopose, whereas other transformers, you see much more deviation. Or here on the hand movement during a vibrato. Our software that really follows closely the trajectory. And here, similar things. This is our software that closely follows the trajectories here shown, red versus green. Whereas other software, for example, if we don't add in audio, then we make a large error here. Green. And other softwares too. They don't get as close to the trajectory. Yeah, so I will attempt at the end to show the software, because I have to switch then Zoom. But that's what it does, the current software. So there's this app, but you set it up, you have to calibrate that you're actually in the image. And then you can run it and it will tell you things like here. It will tell you widen your stance or raise your violin. This is for the posture estimation. And then you can review the software. So you practiced for a while and then you come to a menu where you can review your mistakes afterwards. And this can also be shared with the teacher or your parent. So the next thing we are tackling right now is then helping students with learning bow strokes. And there's a whole repertoire of bow strokes. Yeah, took it out. But détaché, so which are played in a different way. And we in this tabula, I categorize them into the phases that you're doing. You're touching the bow, which is called attack. You have a bounce or not a bounce. You release it, how you release your bow, you release, and you have a transition. And we gave them attributes here. So this is one, there's more to it, but this is one way of communicating to you the different bow strokes that a violinist has to learn. And this is the first repertoire that probably you learn after 3-4 years. Whatever, it's not the beginner. Beginner will just learn 4 strokes, but then you build it up to these 9-10 strokes and add on in your vocabulary. So here it shows how we actually annotate it. For that purpose, Sneha has written actually a program for efficient video, audio, and so annotation. Sorry, can I? Okay, this is just a picture shown. Sorry. So what you see here is in the individual frames, then in yellow, the bow technique. So he will say then from here to here, it's détaché. From here to here, it's martelé. The same up, we can also build up for other things, then giving attributes to what the student does wrong. And this is happening in collaboration with the music department and the graduate students in music that are giving us here things like sound quality, bow attributes. So what you want to do is basically, if you record the student, here it's shown record, you want to recognize what is she playing right now. In this case, it happens to be martelé. And you want to give her feedback on how this bowing is. So it starts with putting the bow on the attack, which I show here as an example. And we can say there's not enough attack. And after she's told, she has now much better velocity, much better attack, faster velocity at the stroke, at the bow stroke. Well, the plan is for experts here to do some reinforcement learning. That's what we are working right now. Basically, the experts will be recorded. And network, that's the current idea. The network we're working on right now, currently training it from video and audio, some code book. That's what code book. So basically descriptions, intermediate descriptions are learned via the network that well represent this whole space of audio. And then the non-expert, the student comes in, does his playing. It doesn't sound as good as the audio. And the reinforcement learning technique is now trained. that learns how to adjust the movements in order to change the sound. And as output, we would like to give the students, so what do you need to adjust in order to get your sound to the sound of the experts via the movement? And the output will be then here instructions on what more dark, longer bow stroke. Your bow is not flat on it in terms of language. Well, another thing we have been developing is a haptic feedback band. So you may also see here. So some band, this is this box that we made over multiple iterations. So what it does, it has vibrating motors inside. And we tuned these vibrating motors, and the way we are evaluating now how to use this in music education. You can, unfortunately, you can use these vibrations, and these vibrations are dum, 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 dum that you're getting. You can put in it like a small language to communicate to the student. Move your hand lower, move your hand higher, or go to the left, go to the right. And I will show you then we are evaluating it also whether it's useful in order to help students learn the rhythm. So they're getting a piece of music that they're playing, and while they're wearing the band, then it's in sync with the individual notes. So there's two different things in rhythm. One is the beat, which is whatever, it's a 3/4 beat, 1, 2, 3. But the other thing is what is each individual note. And these are actually processed in different parts of the brain. So we want to use it to teach rhythmic pattern, the second one, the onset of the note. And we also have the plan to evaluate it in bands or orchestras. So here at Maryland, we have summer camps where students come in, middle and high school students, and they play. And they could be wearing these bands now in order to be getting communication. So the guy in the back who only plays the drums and has to count 50 beats till it's his turn, now he gets the beat. Will help him hit when he should start. Well, so that's how it kind of looks like. You have, yeah, no, it's a screenshot. You have here music, and it tells you, and while you're wearing the music, you can see the expert playing, and you can also wear the band that tells you on each, it gives you a signal, a haptic signal on each note onset when to play. And yes, we are recruiting the students that will be wearing this haptic device in order to evaluate it. It's planned for summer 2024. It will be probably a little bit later because we didn't get the funding yet. So, and then the last, that's also, not last, but one of the things that is now the quality of sound, when you get more to the expert level. An expert has its specific style, and you recognize him. But to get to that level and really have high quality, one thing we're doing is now also describing these sounds, and we recorded from collected different pieces actually from the internet where people play the same piece, and then they our music experts have been rating them on a scale of 1 to 10. Now we try to learn what are, I mean, first of all, classifying into the expertise, and then also give them attributes, and eventually learn how to tell the students to get to a higher level. So this was the Bach Partita number 1. And different players then got these comments. Player 1, so player 2 is the expert, very good control of sound for each note and whole tone. Whereas others maybe slight sweetness of sound, intonation effect. So, and to do that, we have this tool that I mentioned before that the experts are using, on which they annotate the bowing technique here shown in yellow. And then sound quality features like uneven sound, balloon sound, so they will stop and put the attribute. Well, so this is how is data created. And you see it's obviously a huge effort to go through each piece. So at the same time now, in computer science, in AI, everything is going towards using large language models to help them. Modalities are putting together. So you can actually, if you find, we do find videos already where experts are giving comments, you can try to explore this knowledge also to save you, to get extra data for this automatically. But for the moment, this is what an annotation tool would look like and what the effort is. You're going through this video, then you click, and the expert annotator has to give various labels and tell you exactly, for example, from here to here, it's a theta shape, both stroke. So, and then one component I also mentioned is the preparation of etudes, which we're planning to use to evaluate students. So for that purpose, I think it's nearly 400 etudes that Irina is recording professionally, and they are also annotated to what does each etude teach you, what styles. It teaches you this bow movement, it teaches you here some embellishment, and then use this in order to, for example, this etude Wohlfahrt for an intermediate level, you're getting the legato. Your second skills are arpeggios. You're playing in this position that's on the strings. You're having this meter, and the character is expressive. So you will be evaluated on these attributes and then given feedback. What you should practice, how well are you doing it, and what etudes will be helpful to help you. I will also at the same time, I will skip this now, but we're also now getting involved with audio processing. We're also trying to do EEG as a side study where we explore now what we can know, what's the brain actually doing while you're learning. Can we get that out? And the very first thing, because unfortunately EEG is a very, very noisy signal, but it's kind of the only one you can really use in an easy setting. Everything else you have to put. It's very elaborate. You have to put in special settings. So we're trying to just right now do signal processing it, just figuring out how to separate the motion components from the perception component from the signals. And Sneha Shrestha was the first student to do a lot of work on it, and he just graduated. Here Seong, who is now, he's in computer vision with us, but he's also a good violin player. Daniela, who is a violinist, and Alexandra, a violinist, that have been doing a lot of the work. Okay, so, well, I think I will finish it here, and I gave you kind of an idea about the apps. And who wants to stand on, I can try a demo over Zoom of some of the running apps. But let me open it for questions right now.
Thank you very much, Cornelia. This was fascinating. Questions in the room? Manuel.
Actually, I have a couple. Let me quickly introduce myself to the round because I know Cornelia, but I don't know anybody else. I'm currently a postdoc researcher at the George Washington University, so somewhat geographically close to Cornelia. And we had the chance to meet a week ago. And I also do computer vision research, so I was like very happy to see all this like details she gave in that presentation. Really gave me a good understanding of what she's trying to achieve and how at this point. Well, I guess first question would just be, do you already have any papers published on this research?
Yeah, I haven't put them out on archive. We just got the pose estimation with sound and vision published, and we have the data set under submission. And we published something on the which is also on our website on the tactile feedback tool. Yeah,
Okay.
it's most. I haven't linked it up yet because whatever, it will come out at the next conferences, but I'll send you the links.
Okay. And then one more would have been about the idea. You said like the setup is still pretty complex, like it takes some time. They have to come to the studio. So I was wondering if you've tried using, you know, the VR gloves or some sort of tracking gloves instead of the whole tracking setup that students currently have to do. I mean, I think it would be like less key points that could be tracked through those, but it might make the setup a little bit easier. So I wonder if you considered those as well.
Yeah, it could be used for the fingers. You mean especially for the fingers, right? Yeah, actually, we do have now these other systems through the collaboration that doesn't require the markers. It's markerless. So it's much faster setup. You set up in 10 minutes. It's a little bit less accurate because it's only done on the basis of vision and not specialized vision. But so we're designing actually software, again, using this concept of bringing together video and audio in order to first improve the learning data. But for the glove, yeah, it's an interesting idea. The only thing is that then you have the black glove or so in the video also.
Right. So I was thinking you probably have to cut the fingers open or something like that so they can still like actually play.
Right.
But yeah, but there are like consumer gloves out there for VR, for example. I think what is it called? Oh, HTC Vive, I think. They have the tracking glove and it works pretty accurately. But yeah, it would be less data because you wouldn't get the arm and
No, I mean, you
all
can
that,
use it
but
maybe together with the other. Yeah.
or in combination.
Yeah.
Yeah, that's just some idea I had there. Yeah.
The
And it's
question.
actually quite interesting. So, sorry, interrupt me if I'm taking up too much time because I started like research, somewhat similar related research, also during COVID motivated. I was a dance instructor back in Austria in Graz. And so we did like similar recordings for teaching how to dance basically. Is it okay if I show my share my screen like just for a moment?
Time, Manuel, we're almost out of time. Let's not.
Okay.
But we should check. We should connect. This is really interesting. I'm interested
Sorry
in
about that.
dance. Actually, we're doing right now also some collaboration because out of that people keep coming to us on dance. Let's talk offline. Yeah.
Cool.
That would be cool.
I know robots don't have the dexterity yet, but in principle, you have the framework to teach robots as well sometime in the future with exactly that setup, right?
Yeah, definitely, right? Yeah. Yeah.
Another interesting thing I know. So yesterday I happened to see a talk. It was on Parkinson's and a technique called galvanic vestibular stimulation. And the finding is that it's basically 2 electrodes somewhere on the head, and the stimulation helps patients. There seems to be some effect. It would be interesting to see, how people respond to the feedback with this device on and not off versus off. So apparently people do a little better when they, but that's in Parkinson's, but maybe the motor learning, right, that they're performing, there's very similar networks of the brain are involved. So you may actually see what you would have, you have a measurable device that actually sees the benefit directly, right, from, because you're interrogating the brain with all these, the skill acquisition and all these things. It might be actually more interesting than a crude fMRI experiment, which is what we saw yesterday.
Yeah, Dietrich is the expert on Parkinson, but there for motor diseases, music is amazing. So you see these videos on the internet, the Parkinson patient that cannot walk, and then you put on a beat and he walks perfectly. There's multiple.
Yeah, that's why I was interested is that, the generalization and next steps, because I definitely can see a potential for many more experiments in the context of motor learning in the healthy system, but then also basically on the patient system. It is a complex element because you have several elements. You have the emotional element of that. You have the motor learning component. You have cognitive elements. So people work in that field for many years. So I really like kind of that kind of multimodal approach. Use music learning as some sort of a testing ground to work out the mechanics and the interconnections of different systems, to then generalize it to essentially motor learning in the context of disease. So there are several groups also at the NIH that work on that. I worked in the human motor control section, which is exactly doing stuff like that.
Cornelia, I have a quick question. It's like, how do you?
Yes, I have to run to a different meeting.
Okay.
Bye.
Ciao. Yeah, maybe we should talk more. Yeah, I think for health, it's really interesting also.
There are lots of applications here for healthy people and for people who need to relearn. But how do you transition it out of the lab to the end user? And what's your time frame for that?
So we just started a company, the main student, Irina and myself. And having the first app, now we make it just a beautiful web app to actually be useful. And through the connection of the music department, we are giving it to music teachers to fine tune. For example, even for the posture, and so not everybody wants to hear everything, what is needed. Now we need feedback from actual users to get the first thing out, which is the posture estimation, and then keep working at the same time on the other things that I mentioned. Mm-hmm.
It would be interesting to see the setup that people require at home, like how you would actually be able to use it within a regular environment.
Right. Yeah. So, the idea is that you can use it on a handheld device, your iPad or maybe your phone. But obviously, there's a calibration phase. So, So you have to. I mean, the calibration phase just means you need to make sure that you're really in the image and keep. Yeah.
In the interest of time, any other questions in the room? Anybody else? Manuel, if you have one more question that does not relate to your work, but to Cornelia's work, you can have the last one.
No, I mean, it does. I just wanted to show the volumetric recording we did there, because that's, I think, also an interesting aspect there. We have this volumetric capture studio where you can kind of record volumetric stuff. So, and I was thinking like using that in combination maybe with augmented reality or smart glasses. So you can even like overlay some of the instructions during the teaching. And then also you mentioned how feedback could be given using LLMs. So I think like instead of textual or verbal feedback, it could also be visual feedback using overlays.
Uh-huh.
So basically you would like wear a glass and then register your hands with some pre-recorded hands of how to perform a certain stroke, and then it could also visually guide you in case verbal instructions or textual instructions aren't that useful. Just as an additional means of teaching visually, not only verbally.
So do you want to say something to that, Cornelia? If not, it seems like there's a lot of opportunity for post-talk continued conversation.
Yeah. Yeah, we'll definitely connect, Manuel. I have to go now somewhere else, but
Good.
I'll send you an email. Yeah.
Yeah. Thank you very much. This was really incredibly interesting, and I'm glad you shared it with all of us. And we look forward to the continued progress.
Yeah. Good. Thank you. All right. Thanks for coming.
Thank
Ciao.
you.
Bye.
Here.
Thank you.